Hi there, good to see you guys. So today we're talking about SOHCAHTOA and trigonometry, and basically the intro to trigonometry. And this is the video, part one of the video that supports this booklet here, Pre-Calc 11 Intro to Trig. We'll be talking about the nature of sine, cosine, and tangent over here, and we'll also be talking about what those ratios mean and what this SOHCAHTOA means, this guy over there. So this is the first video to support that booklet. And we'll, in the second booklet, we'll look at how to solve for missing sides and missing angles, those sorts of things. Okay, so let's get started. Okay, so you guys remember Pythagoras Theorem, a squared plus b squared equals c squared. Well, this is the same thing over here. And what we can do with this is we can figure out the hypotenuse, right? And if we plug that in, we'll get the hypotenuse value. Okay, and that's it right there, right? 4 squared plus 3 squared equals c squared. Just plug those in, and eventually we get a value of 5. Right? There's the 5. So, okay, Pythagoras Theorem, and that's really the start, or the foundation from which all of trigonometry is built upon, because from this, we can talk about the ratios. Now, ratios are fractions of one side to another. So I'm going to label this side C, this A, and this B, right, to look like that. And our 5 is our hypotenuse, right, HYP for hypotenuse. And the ratios on your calculator, the SIN, right, SIN, that stands for sine, right, that we pronounce that as SINE, has a ratio, depends on which angle you're looking from, but that's the ratio of the opposite over the hypotenuse, and I'll explain this in greater detail shortly. Cosine, or cos, right, which is just cosine, is the adjacent. What the heck does that mean? I'll sort that out in a moment. Divided by the hypotenuse. And the tangent, right, that's what tan stands for, is equal to the opposite side over the adjacent side. So this is the start of trigonometry, and we got a ways to help remember this, and we got ways to help figure things out. So let's have a look at a couple simple ideas before we get into some kind of harder ones. Okay. All right. So when we label a right triangle, like a triangle here with 90 degrees on it, right? If we label that, we usually put C at the 90-degree angle. Its opposite side is the hypotenuse. B, right, and it has its opposite side, and A has its opposite side. So we can label the different sides of our triangle as either opposite or adjacent to these particular letters. Let's see how that works. Right, so there's the opposite of A down here because there's A up here, and all the way across is down there, and same thing, there's B, so opposite of B is up here, right? So we call those the opposite of A and the opposite of B. And then we have another word called adjacent. Now, adjacent is a word that means to be touching. So if I look at angle B here, right, I've got two lines that touch it. I've got the hypotenuse that touches B, and I have the opposite that touches B, right? So the thing with trig is that the hypotenuse always stays the same. This is always the hypotenuse side. So this opposite of A is also known as the adjacent of B. So let's write those out. There's the word adjacent, right? A-D-J-A-C-E-N-T, adjacent. It means to be touching. And every angle, except C over here, but we don't really worry about C, but for A and B, they have two lines that touch the angle. This line and the hypotenuse. For A, we have the up-down, the vertical line, and the hypotenuse. So those lines have two different names, and we need to do it this way until you get to grade 12. In Pre-Calc 12, you learn to do it without having to sort this out. But for right now, this is how we need to manage. Okay, so sine, cosine, and tangent are just ratios or fractions of one side over another. And let's have a look and see what that looks like. Right, sine, cosine, and tangent are defined like this. Sine is defined as opposite over hypotenuse, as mentioned a little bit earlier. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And your first exercises in the booklet are just getting you used to figuring out tangents, sines, and cosines of different triangles. So let me put up some numbers up here, and we'll kind of talk about the very first detail you need to be able to do. Alright, so let's say I ask you, alright, put up these numbers 3, 4, 5, just like we had in the last assignment, and then I ask you to determine the fraction for the following questions. So what is the sine of A? So that means from this angle here, what's its sine value? Now remember, sine is defined as opposite over hypotenuse. So I just look on the triangle, and the opposite of A, because we're talking about angle A there, right? The opposite of A is this line, that's 3, and the hypotenuse is 5. So my fraction would be 3 over 5, which is a decimal, right? You can get the decimal for that. I think it's like 0.6 if you want. But we'll leave it as a fraction for right now. Then if I ask you for the sine of B, right? So sine again is opposite over hypotenuse, but this time we're looking from angle B. So here I've got to find the opposite, right? Because sine is opposite over hypotenuse. So from angle B, I've got to find the opposite. So 4 divided by the hypotenuse, 5. So 4 over 5, which is 0.8. Right, so I'll get you to do a few more, and just let me set it up. Alright, so I could ask you to tell me the cosine of A, or the cosine of B, the tangent of A, or the tangent of B. So why don't you just pause the video and see if you can calculate those on your own. Right, and I'll put up the answers in a moment. Okay, so this is what I got. The cosine of A. Now remember, cosine is different. Cosine is adjacent over hypotenuse. So from angle A, I look for the adjacent of A, which is 4, divided by the hypotenuse, 5, right? So 4 over 5. The cosine of B, right, so I do the same thing, but this time I look from angle B, right? So adjacent over hypotenuse from angle B. Adjacent of B is this side here, so that's 3, and the hypotenuse is 5, so 3 over 5. Bada bing, bada boom, right there. Right? Make that a little closer for you. And then we do the same thing for tangent. Tangent is opposite over adjacent. So there's A, so opposite of A is 3, the adjacent of A is 4, so 3 over 4, and tangent of B. So your first page really is just designed to get you to think about these things. And yeah, sometimes you got to simplify fractions or whatever, but that's just, that's the nature of determining sine, cosine, and tangent. Now the beauty of sine, cosine, and tangent is that when these angles change, our values change, and so our calculator has like a database of all the angles and all their sine, cosine, and tangent ratios, right? I could have, well, let me just pause this for a moment to give you a better description. As you can see here are like two different triangles, right? So if I ask you for the sine of B for this one, well, sine, right, is opposite over hypotenuse, so 5 over 13. Okay, and so this angle here is probably like, I don't know, 20 degrees or something like that. And so your calculator will have the ability to know that and pop it out. It'll pop out this fraction or whatever the decimal is for that fraction. But if I said this was B over here and I asked you for the sine of B, well, I would have 16, the opposite, divided by the hypotenuse, 20, right? So for this sine, so this is sine B, and this sine B, this angle, would be 16 over 20, right? 0.8, I think. And your calculator would know, like, you know, if you knew this angle, your calculator would know the sine value for it, and it would also know the cosine and the tangent, and would have all those numbers. And it knows it very precisely, like to, you know, to millionths and millionths of decimal places. It can know this stuff, which is nice and handy, because in the olden days, if you talk to your grandparents, say, they might have told you, or they might tell you about using trig tables. And we're actually going to see an exercise where we use trig tables to help us determine these details. And that's really what the first part of the booklet is about. So let's have a look at a couple of the ideas from the first part of the booklet. Okay, so on page 1, let's do question number 13, because that's probably the most value for us here. they ask you to tell me the sine of A, right? And so you have to go, okay, was it sine, was it opposite, was it adjacent, hypotenuse, I can't remember. So we have a little memory device that allows us to remember that kind of with a little bit more ease. It's kind of cheesy really, but I'll show it to you here. Okay, so we remember it by using the device called SOHCAHTOA. And so here's how it works. S, sine, right? So this guy over here, S, is opposite over hypotenuse. So. And then ca is cosine, adjacent over hypotenuse. And T, tangent, is opposite over adjacent. So SOHCAHTOA, or whatever you want to think. It's kind of weird, but so this is how we use it. And so what I just encourage you guys to do is just to have it on your page so that it's very quick and easy to remember. So for example, right, if I ask you for the sine of A, well, right, so opposite over hypotenuse. So opposite over hypotenuse, you look from angle A, right, so that's over here. The opposite of A is 20. The hypotenuse is always across from the 90, so 20 over 25. 20 over 25. And then you look in the answers and it's not there. What the heck's going on? It's not there because we need to simplify the fraction, right? 20 and 25, these two numbers here, can both be divided by 5. So that leaves us with 4 over 5. Right, and that would be letter B. So I think what you do is you cross out all the, no, you don't. So for slot 13, you write in the letter B. And you just carry on with that idea. So that's what that page is all about. Be careful to simplify your fractions. That's probably where people go wrong the most. So the next thing I want to do is talk a little bit about page 2, because that's a little bit more challenging. That's using trig tables. Okay, so here we are on page 2, and in the, kind of partway down on page 2, well, here, I'll hold this up for a moment. On page 2, this here is a trig table. Now, in the olden days, this would have been a lot more precise. You have the angles going down here, so different angles for A and B and C in this triangle there. And then we have sine, cosine, and tangent, and these values that you would get, the ratios turned into a decimal. So they say, okay, well, think about this triangle here, and tell me what the sine of 35 would be. So you go to angle 35, right there. You go over to sine column, which is right there. What's that, 0.574? I don't know, it's kind of choppy, but I think it's 0.574. Yep, so 0.574. You look down on the bottom, right there, kind of center middle, 0.574, and so you put down the letter L. Right, pretty easy, and these top 6 are just using the table to come up with those values. The rest of the page requires you to think about whether you're using sine, cosine, or tangent, and then moving forwards and then moving backwards. So let's talk a little bit about the very first one, letter A. So this is letter A, the first kind of like one after the 6 easy ones. And it says, okay, well, if the measure of angle A is 40 degrees, then A divided by C, this ratio, so A divided by C, right? Oh, I got this backwards, I think. Yeah, sorry. This is B, and this is C. Sorry. So if A divided by C, so this side over here divided by that side over there, so little a divided by little c, well, what would that be? Well, that's sine, right? From angle A, because as we're talking about, from angle A, this is the opposite, and that's the hypotenuse. So really, this is just a big fancy way to ask, what is the sine of 40? Because this part is sine, and that part is 40. Right, because we're looking from angle A, right? Angle A, little a is opposite, C is hypotenuse, right? So opposite hypotenuse, that's sine. So that's just asking you to find the sine of 40. So you just go in your chart, right? And you look down 40 degrees and you come across the sine and you see what you get. Sine 40 is 0.643. 0.643. 0.643. So this ratio here of a divided by c, or this fraction of a divided by c, if you took whatever numbers you would get from that triangle with 40 degrees in that spot, you would get a ratio always equal to 0.643 for these two numbers. And that's very, very powerful, right? That allows us to use two kind of unrelated questions or pieces of information to find a third piece, and that's what the second booklet is really all about. So I have one more detail to look at, and then I'll let you guys go, and we'll do the next video shortly. Okay, so the next one down on the list right after A, letter H, says, okay, well, if A divided by C is this decimal, so the ratio of this side to that side, if I took this side, whatever it was, divided by that side, I'd know its value is 0.966. So we can work backwards to find the angle, right? So from angle A, this means sine, right? Because that's the opposite. A is the opposite, C is the hypotenuse, right? So AC, opposite hypotenuse, that's so, right? So we're talking about the sine. So they wanted to know the sine of what angle is equal to 0.966, right? This here's the sine, that there's the number, and they want to find the value of the angle. So you just work backwards. You go to your chart column, you go down sine until you see 0.966, so go all the way down, 0.966, that's 75 degrees, right? 0.966, so that means that 75 degrees is the angle value that gives you a sine of 0.966. So the rest of the booklet is just that idea, right? It's either working forwards or working backwards. And sometimes they change the angle. If I said from angle B, right, so here I'm looking for this angle there, well then A represents the adjacent and C represents the hypotenuse. So adjacent and hypotenuse wouldn't be sine anymore, it would be cosine. And I'd have to say, okay, well the cosine of what angle gets me 0.966. And if you look it up on your calculator, that's 15 degrees. So you got to be careful a little bit about what angle you're looking from. Alright folks, so that's it for me, and stay tuned for the next video that will talk about how to solve for missing sides and missing angles, the last part of the booklet. Take care.